Please like and share this video so that maximum number of engineers may be benefited. Also, please subscribe to YouTube channel to receive the updates about the future events and to receive notification when we go live.
Hello, good evening and welcome to this live technical discussion. So today we are going to talk about dissertation area related to earthquake resistant design. So we are receiving many requests from the students related to the dissertation area. Let us say that how to select the dissertation area, what should be the dissertation area, then how to approach the dissertation area. So based on the request, we thought that let's have this kind of series of discussion specifically for the students. Okay, so before we begin, you can always interact with us through the live chat. So please let us know from which location you are participating. Okay, so good evening, Bhakti. Okay, good evening, Sashank. Okay, so you can share this video with your friends, with your students, so that we can have more participation online. Okay. So Dr. Ajay Shah is also with us. So very good evening. And I could see there are few practicing engineers also. So I'll request them also to suggest the area in the chat box. So overall idea is to bridge the huge gap between the industry and the academics. Okay. So generally, whenever, let us say, the students are selecting the topics, they may not be aware about what is the real practical difficulties into the industry, and the industry may not be able to approach the students. Okay. So this is a small attempt towards bridging that gap, wherein let's say we can list down the areas based on the real practical difficulties in the industry. Okay, so that whatever dissertation areas which you are selecting as a student, which will have a real meaningful value when you actually get into the practice. Yeah, so very good evening, Brijesh. Okay, good evening, Atul. So he is walking, he is into the PB design, PB building design. Good. Okay, so good evening, Saijat. Yes, everything is fine. I hope everything is fine at your end as well. Okay, so good evening, Raj Kumar. He is joining from Hyderabad. Good. Okay, so once again, I'll request all to share this video with in the other relevant groups so that we can have more participation. And I'll also request all online practicing engineers to suggest the dissertation area in the chat box based on whatever practical difficulties, let us say, you are facing with respect to your day-to-day design cycle. Okay. So this is a small attempt towards the bridging the huge gap between the industry and the academics. So if you have not yet subscribed to this channel, then please do subscribe. And we are having quite aggressive plan of having this kind of live discussion. So you can always suggest the areas on which we can have the live discussion. So generally we are arranging the live discussion based on the practical difficulties in wherever in the industry, right? On that area we are arranging the discussion. So you can also suggest the areas through the chat box to us, and definitely we will prioritize those areas, and then we will arrange the discussion. So very good evening, Sumit. Okay. So see, whenever we talk about the dissertation, then this is what I used to say, that this is one of the most important part of the post-graduation program. And actually I'm used to say that this is the heart of the post-graduation program. And this is very, very much important, right, in the overall academics with respect to, let us say, the post graduation in the structural engineering. Okay, good evening, Imran. Good evening, Prithviraj. Okay, so let us begin now. So this is what I was just telling, that whenever we talk about dissertation, then this is the most important part of the post graduation program, in my opinion. And how actually it is helping us, this dissertation area into the industry, because generally I'm receiving that comments from students whenever I'm interacting, that that dissertation is not at all useful because it is just kind of a theoretical exercise. But always I used to say that whenever we talk about dissertation, actually it helps us creating a process for doing the research work. Now let's say you might say that in the industry we do not have to do any research, but actually in the industry we have to do research, but actually the time of research is very, very less. Sometimes we can say that it is, let's say, 1 month of time, 1 week of time, and sometimes we have to give our decision within, let's say, 1 hour, or sometimes in minutes and seconds. So at that time, this dissertation, in my opinion, it helps us to give the decision, or rather to make the decision based on the structured process, that is starting from the let us say the literature survey, then the collection of the data, then doing analysis, our own analysis, and then finally preparing conclusions. So that's the way I believe that the dissertation is very much important with respect to our day-to-day design cycle into the structural engineering. Okay. So how to select the appropriate area for the dissertation? This is the common question which I think all students might have, and this is the questions actually we are receiving frequently. So this is what my answer to this question is, that the civil engineering is everywhere. This is what I'm used to say in my corporate journey, that civil engineering is one of the oldest branch of engineering. And that's why we can say that the civil engineering is everywhere, and civil engineering is a vast field. So with this, each area of civil engineering is also a vast area, meaning let's say if we talk about hydraulics, irrigation, structural engineering, transportation engineering, there are so many branches of civil engineering, and each branch of civil engineering is also having same characteristic rather. So that means each branch is also a kind of a very vast area. Okay. So this is the general process I would suggest, in my opinion, that how to select the appropriate dissertation topic. First of all, you must identify your area of interest or passion, because as I told you that it's a vast area. That means there are ample number of topics from which you can select the area for the dissertation, or let's say the area for research for your masters, or even for your, let's say, for your PhD work. There are ample number of areas. So that's why we have this liberty wherein we can identify our area for the interest or passion. And then the second step is very much important, in my opinion. This is the two-step process which I generally recommend to the students, in my opinion. Okay. So in the second step, align this area with the practical difficulties which is being faced into the industry to narrow down the research area. So for the second step, you must interact with the industry professionals and then try to collate what are the practical difficulties with respect to your identified area of interest, or let's say the area of passion, etc. And based on that, you carry out further literature survey, and from that I think you can narrow down, or you can pinpoint your area of the research work. Okay. Yes. Okay, I can see some comments are coming up from the participants, so please feel free putting up all the points. I'll take it up sequentially as and when the time permits in between. So this is one of the video which I published before a couple of years, and there was a great response from the students on this video. So let's say if you have not yet seen this video, which is giving 30 broad areas related to dissertation, you can see on the YouTube channel, it is there. Okay, so now let us come to our today's discussion. So as we have discussed briefly that the civil engineering is the vast area, that means structural engineering is also a vast area. So whenever we talk about a dissertation area, there are actually ample number of dissertation area, or even we can say the different verticals even in the structural engineering. So today for or rather to have a very focused discussion, we have selected only one area, which is earthquake resistant design. And in this area also there are again ample number of topics which may be taken up, or rather which may be further explored for the dissertation. But what I'll be telling or rather I'll be sharing now would be few of the area. It's again not a complete list, it's just only few of the area from which I think you may get a hint for further exploration, or rather for the further work. And in the subsequent session, now we are planning to have this kind of a discussion exclusively for the students for the different area, like let's say for the wind engineering, or let's say for the water retaining structures, RCC structures, steel structures, etc., etc. The list goes on, for let's say retrofitting, etc. So whatever areas now I'm going to suggest now, those all are very broad areas. Okay, and these areas I have collated based on the practical difficulties in the industry, so that let's say if you work on this area, then this would be more meaningful in my opinion. And definitely the literature survey is required for narrowing down the topic and for defining the exact scope of the work, because it's a broad area which I'll be suggesting now. And after doing literature survey, you may arrive at a specific topic with the action plan, and then always consult your internal guide for further guidance on this. Okay, because again you have to meet your specific academic requirements, so based on that you can decide the further action plan in consultation with your guide. Okay, so these are the few topics which now I am sharing with respect to earthquake resistant design, which may be further explored for the dissertation. So first topic is impact of vertical earthquake force on the different types of structures. So as you may be aware that now as per the latest amendment number 2 of IAS 1893 part 1 2016, now vertical earthquake force needs to be considered for majority type of structures, whether structure is supported on soft soil or if it is having some kind of irregularity, and there are different conditions given. So with this we may say that for majority of structures this impact of vertical earthquake force may be required to be considered. So this may be one of the dissertation area in my opinion, wherein you can take up few different types of structures, and then you can study what is the exact impact of vertical earthquake force on those different type of structures, with and without considering vertical earthquake forces. Okay. Yeah, second is consideration of torsion, irregularity, and remedial measures for different types of structures. So as you must be knowing, in IS 1893 Part 1 2016, the torsion irregularity clauses are introduced. And let's say if we talk about actual structures, then definitely this torsion irregularity will be one of the critical irregularity, because generally our buildings are not regular to meet the function and the aesthetic requirements. So you can choose a few different geometries, and based on that you may work out few thumb rules, methodology, guidelines, that how torsion irregularity can be mitigated, or what could be remedial measures. Okay. Okay, Virendra Singh is telling that thank you for conducting this session. Most welcome, and it will be helpful for the students who want to publish paper on seismic design topic. Yes, absolutely right. The next topic is impact of rigid versus flexible diaphragm on the overall behavior of different type of structures. So now there is a provision of rigid diaphragm versus there is a flexible diaphragm if you refer to IS 1893 Part 1 2016. Now if we talk about certain software, then there is a methodology, or there is a provision of semi-rigid diaphragm which is not included into the Indian standard code. So these different kind of diaphragms may be considered in the structure. And of course, for different diaphragm, the definitions are given when to consider rigid diaphragm, flexible diaphragm, and what exact or what kind of effect really it is making on the structure, that may be studied, in my opinion. So what I'm suggesting right now is just a very broad area, and I'm just touching, I'm just giving the brief of that area. So if you want to know very specific details about it, then you may contact me separately, and then we will discuss it. Okay. The second interesting topic, what in my opinion, is the different percentage of the shear wall. So now, as per IS 1893 Part 1 2016, whenever we have a soft story, then in that case we need to provide shear wall with a SPD. SPD is the density of the shear wall in the plan, we can say, and it should be minimum of 2% in each principal direction. So if we talk about earlier IS 1893 Part 1 2002, so at that time there was a clause for kind of a penalty clause which was given, like whenever we had a story, soft story, then we need to increase the forces by the factor of 2.5. Now that factor of 2.5 is removed, and against that, now it is said that we need to provide the shear wall with a minimum percentage of, let's say, 2% of SPD in each principal direction. Now this may be one of the area which may be taken up, like what is the impact on the performance of the structure with a variety, with a different percentage of the shear wall, let's say 1%, 1.5 percentage, 2 percentage, 0.5 percentage. Of course, you may require to perform non-linear dynamic analysis, pushover analysis in all the topics which I am suggesting, but this may be one of the interesting area. Okay, Sajad is telling, if we design any building for earthquake, then how can we get to know up to what scale, magnitude of earthquake the building would be safe? Great. So if I speak in a general term, that whenever we are designing as per Indian standard code, then generally the buildings will fall in the range of collapse prevention stage, in my opinion. That means building will suffer the maximum damage during extreme seismic event, but it will not collapse. But this can be analyzed, like now how, what is the magnitude or what is the scale exactly those building could sustain before collapse. That definitely uh, can be examined or can be analyzed through the advanced analysis. So this could be also one of the interesting area for the dissertation, wherein you can design the entire structure as per Indian standard codal provisions, latest Indian standard codal provisions, and then verify or validate its performance, that up to which scale or magnitude it can sustain. Right? Now, in IS 1893 Part 1 2016, you may be aware that now for the infill brick wall, there is a special provision. So, let's say if there is a certain percentage of the brick wall which is there in the structure, then mandatorily we have to model this infill brick wall. Now, a modeling of this infill brick wall would be again uh, again, vary from the engineer to engineer, in my opinion, because we might have to create different models probably to simulate the reversal of the earthquake direction, maybe based on the limitations of the software. But overall topic which I have suggested here, that what is actual impact, or whether we consider the infill brick wall, or let's say if we do not consider the infill brick wall. Okay, because let's say when we consider infill brick wall, what will happen, the time period of the structure will reduce substantially, structure will become rigid, right? So at that time earthquake forces will be higher, and at the same time, because of the effect of the struts, the forces in the members would be reduced to the certain extent, whereas in the another model, the building will be more flexible, which is without infill brick wall. So in which time period will be definitely relatively higher, earthquake forces would be lower, but the member and forces would be on the higher side. Okay, now is code also suggests that we have to design for the considering for both the conditions, that is with and without infill brick wall. So this could be one of the area which can be further examined. Okay, Naim is having certain question about infill of brick wall. Like, infill brick wall is poor performance in out of plane moment. Second thing, software like ETABS has no direct option for infill brick masonry. Yes, Naim, in my opinion, first of all, where we should consider this infill brick wall, I think that also we need to discuss and debate. So generally speaking, see, I believe we can consider the effect of infill brick wall only if there is a positive connection between the brick wall and the column. Now let's say, as per the construction sequence, first of all the RCC skeleton is constructed, and then brick wall is just used as a filler material, and there is no positive connection except just joining mortar in between the brick and the column. So first of all, I am of the opinion that for considering the effect of infill brick wall into the structure, there has to be certain positive connection. Okay, that needs to be detailed out. So in our few projects, we did it. We created certain positive connections after, let's say, by putting certain amount of, let's say, U bar into the brick masonry, which were anchored into the column also. So we tried to simulate some kind of a positive connection. Okay, now your second question is software like ETAB has no direct option for infill brick masonry. So that's what exactly I was touching upon here, that there are certain limitations in the software. So because of that, we might have to consider, or rather we might have to formulate different models. Okay, and it may be a little bit challenging, because we have to pull out the member and forces from this model, but the further exercise can be carried out, wherein even this methodology for considering in the particular software can also be suggested during the dissertation work, in my opinion. Okay, Rahul is telling, as the time period gets lower, the earthquake forces gets higher, right? So whenever structure is becoming rigid, the time period is going on the lower side, and then earthquake force is increasing. Okay. Now in IS 1893 Part 1 2016, there are provisions given for the irregularities, and irregularities are divided in two parts. One is the irregularity in plan, and another is the irregularity in the vertical direction. And for each irregularity, there are now mathematical limits given, that for, let's say, up to certain extent, the let's say particular irregularity is allowed, but beyond that certain mathematical value, we will have to take a necessary action. And now those action vary upon the limit what we are crossing. Okay, so the subject what I have mentioned on the screen, which is developing a thumb rules to avoid the mode irregularities in different types of structures. So right now I have just highlighted only one of the irregularity, which is mode irregularity. And for the mode irregularity, as you may be aware, that there are 2 3 conditions given. So first is 65 percentage of mass participation, then there is 10 percentage of difference between, let's say, first and second mode, etc. And let's say the first mode shall not be torsional mode. Okay, so those are the kind of a mode irregularities. So for that, the different types of structures may be analyzed, and maybe certain thumb rules may be developed, which may be helpful into the industry. Let's say before getting into some rigorous analysis based on certain equations, thumb rules, the severity of this mode irregularity may be examined. Okay. Yes, this is interesting topic. Now, let's say it will happen in certain cases, or let's say in rare cases, that we are not able to fulfill the requirements of the code, maybe because of the aesthetic requirements, functional requirements. Now, what should be done in such cases? So, first of all, those structures will be considered as a code exceeding structures because we are not meeting the requirements of codal provisions. So, so those kind of structures or geometry may be created, and performance of those geometry may be examined through the advanced analysis. And right now I have mentioned the irregularity point of view. So let's say, as we just discussed, that there are set of plan irregularity and the vertical irregularity. So certain irregularity or mix of irregularities may be taken up, and then those performance of structures may be studied. Okay. Now this is a big topic in I think. So as you may be aware that in IS 1893 Part 1 2016, there were stringent provisions added for the design of flat slab. So the drift was controlled, or rather it was limited to 0.1 percentage. And also we need to consider the stiffness modifiers. Okay. So with these, in my opinion, on paper, majority of the flat slab structures which might have been designed earlier before this code would be unsafe on paper, in my opinion, and because the drift is now restricted to a very stringent level. Now let's say those structures are already standing. So now, what mechanism, what needs to be done for those kind of existing flat slab structures which are not meeting requirements of current provisions of the Indian standard code? Okay, so this is one of the area. Okay, thank you, Praveen. So you may also suggest certain areas in your opinion. See, another area which I think of is the time period calculations. So right now we have the formula for the time period in 3 category. So it's, let's say, the formula is running for, let's say, para is para A, para B, para C. So there are 3 types of structures rather have been considered in the time period formula. But according to me, these 3 formulas needs to be expanded based on further rigorous study. And definitely, in my opinion, in the future versions of Indian Standard Code, we will see more refined formulas. So I think this is one of the area where further work can be done. Okay, because right now the formulas which are given, that those formulas might have been derived from the limited study of the buildings. Now those formulas may not be exactly fitting with respect to, let's say, the real project scenarios. So that's why I was thinking of this topic, wherein the different geometries, different types of geometries may be taken up. Even different irregularities also can be mixed up, and then that time period can be studied, and then it can be compared with the Indian Standard Code also. See here, this is the estimation of displacement based on unscaled forces versus scaled forces for different types of structures. Now there is one interesting clause which is added in IS 1893 Part 1 2016. That is, whenever we are checking, or let's say we are reviewing the displacement or drift, at that time the earthquake force need not be scaled. Okay, so as you may be aware that first of all we need to derive the base shear based on the dynamic calculation, let's say based on the response spectrum analysis, and then we have to consider the earthquake force with respect to the equivalent static method, which is derived based on the empirical formula. And there is one more values given, which is the minimum earthquake force for the structure in the particular zone. So this is the way we will define our earthquake force. And let's say our earthquake force by the response spectrum or dynamic analysis is lesser than these values, then we need to scale up those forces. So in all the cases, we have to consider the minimum required earthquake force, or rather minimum defined earthquake force as mentioned in the code. And also we need to scale up our earthquake force with respect to the equivalent static method, and the earthquake force whatever we derived from the empirical time period formula, what we just discussed before few minutes. Now there is a school of thought from few practicing engineer that let's say if we are not scaling our earthquake forces for checking of the drift, then it may not be conservative for certain structures. Of course it's not for all kind of structures, but this is what some discussion points, some debate or discussions we were having. So that's why this is the area which just came to my mind, and I have just mentioned here, wherein the estimation of displacement or drift can be checked with respect to unscaled versus scaled forces for different types of structures, different geometry of structures, and based on that this arguments or debate whatever we are having, then it will be having some certain kinds of facts and figures for further study. Okay, Sajad is telling for high-rise buildings, say 30 floors or more, let's assume first 10 floors are occupied, next 11 to 16 are empty, and again 70 to 23 are occupied, and rest above are empty. How such assumption is incorporated in the design process? So right now, see, there is no provision of such kind of a scenario into the design process, in my opinion. Yeah. So that also may be studied, because let's say it may lead to some kind of a mass irregularity, probably. That's what you want to highlight. Okay, Akash is telling long-term effects of regularly occurring low intensity earthquake on buildings in zone 4 and 5 can be a research topic. Yeah, this is very interesting topic what Akash has suggested, that what is the long-term effects of regularly occurring low intensity earthquake. Let's say if our building has to sustain just only one earthquake throughout its lifetime, then it's a different scenario. And let's say if it has to, so for example, let us say if the building has to sustain one major earthquake for its lifetime, and the second case what Akash is suggesting, the same structure has to withstand, or rather has to sustain, let's say the low intensity of earthquake, but they are repeating in number of times throughout the lifetime of the structure, then definitely I think the second case will be more critical, because it will require certain maintenance, repairing, etc. And if it is not done properly, then that earthquake which is mentioned by Akash would be more critical. So this is an excellent topic which can be studied further. Yes, one more interesting area is the soil structure interaction. So as per IS 1893 part 1 as well as for the part 4. The soil structure interaction may not be required if our structure is sitting on hard strata. In all other cases, soil structure interaction is required. So meaning if our structure or foundation is resting on the hard strata, then the soil structure interaction may be avoided. And if it is sitting on, let's say, soft strata or the medium soil strata, then the soil structure interaction is required. So we may say that it would be required for the majority of the structures. Now, how to perform the soil structure interaction in a different software, that also is a it would, or rather it would vary from software to software, but this could be one of the area where the actual soil structure interaction can be studied. So first of all, normal conventional analysis design can be done, and then soil structure interaction can be done as per IS 1893, and that impact on the structure can be studied. Yeah, this is again very interesting topic in my opinion. See, if we are referring to the response reduction factor, then this response reduction factor is dependent only on the structural system. It is not dependent upon the height of the structure, width of the structure, then let's say the type of irregularity it is having. Irrespective of that, the response reduction factor is defined for a structural system. So it is only varying with respect to the structural system. Now, according to me, the height, width, irregularity, as well as other factors will also have impact on the response reduction factor. So this could be one of the interesting exercise in my opinion, wherein particular structural system may be taken up, and then height, width, irregularity can be varied for the structures. So out of that, the response reduction factor may be evaluated based on the advanced analysis. Okay. And this can be taken up, like this is for similar top exercise can be taken up for the SMRF, dual systems, etc. Okay, meanwhile there are 2-3 more areas coming up. Okay, Satyam is telling performance based wind design of RCC tall buildings. Performance based wind design of RCC tall building. Okay, so right now let us park this point, because this is a very interesting point you suggested, but this definitely we'll talk upon whenever we will take up wind engineering as a topic, because there are certain more inputs which I want to give onto this topic. But this is an excellent topic which can be further studied. Okay, Saijad is telling maybe ductile or fatigue property of reinforcing steel under earthquake could be a topic, as steel bars continually moves forth and back during earthquake. Yeah, this is the excellent topic, Saijad. Now see, whenever we talk about pushover analysis, or let's say the advanced analysis, or let's say the nonlinear analysis, then this is the most important parameter, which is we define it as a hinge property. Now there are significant research done on this area, but definitely this is also very interesting area which may be taken up for the further research work, because entire analysis results is actually dependent upon this nonlinear property, what we are defining and what we are giving as an input into the software. Okay, Akash is telling low-rise structures in Bachau constructed after 2001 earthquake as a part of relief work were in poor condition. The last time I visited and can be looked at. Okay. Rahul is telling there is now a US code on the wind-based performance-based design. Yes, you're absolutely right. So for the Whenever we talk about performance based design, see, it is related, not only related to the earthquake engineering, it is related to wind engineering, fire resistant design, etc. So that's an excellent topic which you have suggested. Okay, so right now the topic which is coming on the screen is analysis and design of code exceeding structures based on IS 16700. So just before we talked about code exceeding structures, let's say with respect to IS 1893, and we talked about few irregularities. Now in IS 16700, very detailed out procedure is given in the annexure. So wherein let's say if our code, if our structure is code exceeding structure, then step by step very detailed procedure is given. So certain tall structure may be taken up, and then it may be considered as a code exceeding structure by not following certain provisions of the code, and that performance of that structure can be studied with the procedure which is outlined in the IS 16700. Yeah, this is one more area coming up, like design of shear wall manually as per books, literatures, etc., versus design of shear wall in the popular software. Because generally we are receiving so many queries in this area, and the practice is generally varying from design office to design office when it comes to the design of shear wall. Okay, so this could be one of the interesting area. Meanwhile, Praveen is telling, nowadays in high-rise building found cracks near column, initially minor to major. What its behind cause, seismic or settlement, etc. Okay, now it needs to be studied. There are there are multiple reasons for the cracks. So if you can share a few more details, then we can discuss it. Okay, Sahijad is telling, very informative live technical discussion. Yeah, most welcome. And one more topic, Akash is suggesting risk assessment due to earthquake induced fire building of a particular city. Yeah, that is also a good area, because generally after earthquake the fire also may be triggered, so that risk also may be assessed. Now the performance of a buildings with these strong column weak beam theory concept. So in the latest code, it is defined that we need to consider 1.4 time strength of a column with respect to the strength of the connected beam. So that means the column should be 1.4 times stronger than the beams. So this may be one of the exercise wherein different ratios may be taken up, and then the performance of the structure may be studied further. Okay, now when we refer to IS 13920, then the in the initial part of the document, it is mentioned that the nonlinear dynamic analysis is required whenever, let's say, we are having the structural system different than the monolithic structures. So let's say if we are going for the precast structures, or let's say the post tension structures, or let's say flat slab structure, so in that case we have to showcase that there's that different structural system is also exhibiting similar kind of a ductility uh, as compared to the monolithic construction of, let's say, the reinforced concrete and beams. And for that, non-linear dynamic analysis is required, and also it is suggested that the real experiments needs to be done for the structural system like precast or post tension, flat slab, etc. Okay, so here this is the topic which I have highlighted. Now, of course, it's a very vast area. So for dissertation, always, as I told you, you can always narrow down your research work. But this is a broad area which I am suggesting, which is performance of precast structure during extreme seismic event. So with this, a couple of more areas will come up, which is the performance of post-tensioned structure during extreme seismic event. And this is one more area, in my opinion, which is analysis, design, and behavior of the composite columns during the seismic event. So at present, we do not have specific clauses related to the design of composite columns in Indian standard codes, and also there are no provisions related to the earthquake resistant design provisions for the composite column. So this may be a very good topic to explore it further. This is related to the impact of basement, because let's say if we talk about the tall structures, then basement is would be required in the bottom part of the structure. Now let's say if we are modeling the basement, then it is having impact on the dynamic behavior of the tall structure. So this is what I am suggesting with this topic, that what is the impact of analytical model in terms of a dynamic behavior with and without a basement. Okay. Stiffness modifiers. So on the stiffness modifiers, and there are so many queries, so many questions we are receiving. So from that, I have put up this topic, which is a comparison of the design results for different kind of structures with and without stiffness modifiers as per IS 16700. So there may be certain factors by which let's say maybe developed for a defined geometry and structures, that how much impact it is making in the end results. Okay, and this is the final topic, which is design of gravity columns as per IS 13920. So as you may be aware that in the code, it is said that the gravity column needs to be designed for the R times displacement. Okay, and then there are clauses given in the code that with respect to that modified model, that means if we apply that exaggerated displacement on the structure, then whether the gravity column is able to carry that bending moment and shear forces or not. Based on that, different clauses are given in the code. So this could be also one of the interesting area for the dissertation. Okay, so these are all few of the areas, in my opinion, related to earthquake resistant design. Still there are many topics which may be taken up for the earthquake resistant design. So few of them I have attempted to highlight it here, and I think it may be useful to you. So meanwhile, now we are going to close this session, let's say within 5 to 10 minutes. So you can share your feedback, comments, or let's say you may also suggest different topics. So Akash has suggested one of the topic here. Quantification of factors affecting achievement of economy in construction without compromising on safety in the selection of structural systems in zone 3 and 4. So Akash is talking about the optimization of the structural system considering different clauses of the code, let's say in the zones 3 and 4. Okay, yeah. Okay, nice to see you, Professor Mainak Ghoshal. And we are glad that at least certain doubts are clear. Okay, Sashank is telling, can we have a vote for the next discussion topic? Okay, Sashank Tyagi has raised a very interesting point. Yes, definitely we can have a vote for the next discussion topic. So what I would suggest, if you can start writing down your proposed topic of discussion right now only in the comment box, in the live chat. Whatever comes to your mind, you please start writing down into the comment box. And also whenever, let's say, this video is published on YouTube, you start mentioning your desired area on which we should have this kind of discussion. Okay, so from there we will collate all the data, and then we will prioritize the discussion. Okay, great. Imran is telling, if possible, we expect the next topic on wind engineering. Great. Okay. Rahul is telling the usually popular topics like fragility curves. Yeah, there are many dissertation topics being worked out on the fragility curves, and there are many queries we received related to this, that how to form the fragility curves. You're right. Sandeep Chauhan has said very important point. Chapter 12 of IS 800. Yes. So in chapter 12, even each clause can form one dissertation area, in my opinion. So that chapter 12 also we can discuss in the similar way in the detail, right? Great. Okay, Sashank Tyagi has said pre-engineered building. Yes, pre-engineered building is also a very, very important topic nowadays, where a lot of queries are coming. So that also can be taken up. Please feel free to share as many points through email address as well as through the comment box. Okay, so we are closing this broadcast now. We are signing off, and we will meet very soon. Okay.